Topic 8, binomial distributions. Before we talk about specifically what these are, binomial, there should be a clue here what we're thinking about in terms of the number of things. Bi, and hopefully you remember, oh, that's two, like a bicycle, it has two tires, bi. So we're looking at something to do with two. Now the binomial distribution itself looks very specific. Actually, it's a special case of discrete random variables that often arises. And it happens frequently enough that it does have its own name. You may be like, well, wait a minute. Can we go back for a minute? Discrete random variables. Let's go back and take a look and see what those are. Just as a reminder, a discrete random variable, first of all, it's a variable whose values are numbers. And also it's discrete only if it can only take on isolated points on a number line. So there's a finite number of values. So let's start with an example. A lot of times that's the easiest way to get in and see how these actually work. Suppose you're taking a multiple choice quiz for which you randomly guess among the options on every question. And it would be, it's not like if you get number one wrong, you can't get the rest of them right. They're each independent of each other. There are 5 questions with 3 options to choose. Well, in this case, we're going to guess from for each question. So A, here are the 5 questions with 3 options each. Circle your answers. So please take a moment, pause the video, and circle an answer for each one of those. Well, I didn't have any other information. There's no information here, so I just chose C, B, C, B, C. Okay. Well, are those the right answers? Well, no, actually, the right answer, if you had the answer key in front of you, they're all A. Yeah, all right. So how did I do with my guessing? Well, hopefully you can see right away, I got none right. Well, now we're going to let the random variable X be the number of questions that you answer correctly. So you either get one correct or you get one incorrect. Why is X a discrete random variable? Well, the outcomes are numbers, where in this case, it's the number of questions you answer correctly. And we can list out all possible values, possible values of the outcomes. So what are possible values for X? What can X be? Well, as you can see, I got them all wrong. You may have gotten 1 right, 2 right, maybe you got them all right. What's the best case scenario? Well, hopefully you're like, well, as you just said, I could get them all right. And then I could get anything in between. So those are my possible values of X. And of course, this is big X. Determine the exact, in other words, theoretical probability that you answered all 5 questions correctly. And which rule did you use for this calculation? Remember, we want to use good notation. So the probability that I get them all correct, and there are 5 of them. Well, let's look at the first one and see how we're going to figure this out. How many options are there? And hopefully you think, well, there are 3 options, A, B, or C. How many of those are correct? Well, only one of them is correct. So that's for number 1. Are we going to do the same thing for 2, 3, 4, and 5? And hopefully you think yes. Remember, if I get one right or wrong, it does not affect what happens to the rest of them. All right, so in other words, it's 1/3 to the 5th power. And this ends up being 0.004. Which rule did we use? Well, looking back, if you look back in your notes, you'll see we use that multiplication rule for independent events to determine the probability that you answered 0 questions correctly. Well, once again, if I think about it, I'm like, okay, if I look at this up here, there are only 3 options, but 2 of them are wrong. All right, 2 out of those 3 are incorrect. And once again, you can probably see, well, I'm guessing it's going to follow this pattern here. And actually it does. 2/3 to the 5th, and this ends up being 0.132. And we use that same multiplication rule for independent events. Now, part E gets a little more challenging. Determine the probability that you answer exactly 2 questions correctly. So in this case, P of X equals 2. Now, here's a hint for us to do on this first one. We need to find the probability of one particular sequence with exactly 2 correct, then multiply by the number of such sequences. So please make sure you leave a space here as we do this. I'm going to leave a space right here. Let's think about it. We get 2 right. All right, so what's the probability that we get, let's say, on each of the ones? To get it right, it's 1/3. So we're saying, okay, let's say we get the first 2 correct. We're only going to have 2 correct out of the 5, so the rest of them are wrong. So this is the probability for this to happen. These are the probabilities. So these are our correct, and these are our incorrect. Now, is that the only way that that can happen? Well, let's use C for correct and I for incorrect. Let's think about this. We could do the first 2 correct, and then the last 3 incorrect. We could also have the first one correct, and then the middle 3, and the first one, excuse me, correct, the middle 3 incorrect, and the last one correct. Does it matter if I answered number 1, then number 2 correct, or if I did number 2 first because it was easier? No. So does order matter? And hopefully you think, well, no, order doesn't matter. And hopefully you're thinking, wait a minute, I need to count. I'm trying to come up with a number of the times that this occurs. We have 5 questions, and we want to get just exactly 2 right. It doesn't matter what order that we choose, whether we get number 1 right and then number 2 right, or number 2 right then number 1 right. Order doesn't matter. All right. So we're looking specifically for 5, choose 2. Now, this is where we're using that combinations idea again. How would we then calculate this? Is there another way I could write this? Well, sure. I'm going to leave this as 5, choose 2, and I'm going to simplify this a little bit. I'm going to first of all change this to a decimal just so that we can see it, and we know we can see it a little bit more clearly. At least for using my calculator, I can see it more clearly. I've got 2 correct, and then I have 3 incorrect. What do we do now? Well, we need to do 5, choose 2. And hopefully you remember that's 5 factorial over 2 factorial times 3 factorial. And that's going to give us 10 combinations where there are exactly 2 correct and 3 incorrect. Could we have written those out? Sure, but it's time consuming and it's easy to miss one. So out of the 5, we got 2 correct. So that's 5, choose 2. Remember, this is the number of times that the combination can occur, or the number of times that the order can occur. Number of times arrangements can occur. Order does not matter. Order in the sense of which one I choose first to be correct. If I multiply that all out, I'm going to end up with 0.329. As you can see, I didn't want to get squished in here, so I moved the answer down here. Now, what if I wanted to determine a general expression for the probability that you answer X number of questions correctly by randomly choosing or randomly guessing on this 5-question, 3-option quiz? Well, let's see. Right now, we're looking at exactly 2 here, but what if we want to change the 2 to some unknown number X? Can we use what we have? Sure. I can say, well, probability of X. Now, that number is going to be somewhere between 0 and 5, but I don't know. So this is our general, and this is the specific number we're looking for. We said 5, choose 2, and that happens to be our X. Well, we're going to do 5, choose X. And then we did, okay, the number that we got correct which is the 2 here. So we're going to do the 0.333 to the x power. And then the rest of it, 0.667, remember these two, or hopefully you saw these two, 2 plus 3 has to total the 5. That's here. We want to account for every possible arrangement. So if you think, well, okay, I've got x here and I need to get to 5, it's like, well, how would I get there? 5 minus x. You think about it here, I had 2 and this got me 3, so 5 minus 2 gave me 3. But what if I want to generalize this overall, the situation to an exam with n questions and a probability p answering any one question correctly? And we want to now determine the general, in this case, binomial probability distribution. Once again, we're going to choose x correctly, but instead of the 5, we're going to go to n. It's going to be n questions, choose x. Instead of our probability being 1 out of 3, we're going to just change it to p, and we're going to get x correct. You're going to notice those go together. Now, to be valid, the probabilities have to total to 1. You'll see here we've got this plus this equals 1. So now if I do 1 minus p, if I add those together, I'd get 1. And once again, I'm going to do n minus x. I'm not going to ask you on an exam to derive this or to work this out, but I wanted to make sure you understood where this came from. Now, for the sake of completeness, also find the probabilities of answering exactly 1, 3, and 4 questions correctly. So in this case, let's see, we want exactly 1 correct. I'm going to do 5, choose 1. We're going to get 1 correct. And then we're going to get the rest of them incorrect. And that's how you would write it out. I would like you to take some time to actually write those out, to figure them out, but I'm going to give you the answers so that you can check yourself. If you're struggling, please come to office hours for help. This is called a probability distribution table. In this case, it's even more specific. It's the binomial probability table. Either one of those is fine. You also can look at it as P, excuse me. I look at here, P, the probability of X given little x. And I'm going to, like I said, give you this completed table. Some of these we've already done. The rest of them, though, I urge you to practice to make sure you know how to do these calculations. The total of the probabilities to be valid has to be 1, and there are no negative probabilities, and each of the probabilities is between 0 and 1 inclusive. So, looks good.